Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on IGCSE math practice questions. This time the topic is derivatives. Let's start. Question 1. Y equals 3x squared minus 4x plus 7. Find the derivative of y. Well, this is quite a straightforward question. So dy by dx is going to be equal to dy by dx of 3x squared plus dy by dx of 4x plus dy by dx of 7. Oh yeah, it's not 4x plus, it's minus 4x, sorry. But still, at the end we get 6x minus 4. So how did I get 6x minus 4? Of course, we take the derivative of each term, which I've done here. And taking the derivative is simply bring the power down. So in this case, it was 3x squared. We bring this power down and multiply by the whole thing. And then we subtract 1 from the power which we have. So we have 2 times of 3x to the power of 1. And that's 6x. And that's how you got the 6x here. And now the minus symbol carries down. Dy by dx of 4x. So we can write this as 4x to the power 1. Bring this power down, it becomes 1 times 4x to the power of 1 minus 1. Same steps we did in the previous one. So that's going to be 4x to the power of 0. And that's simply 4. So we got the minus symbol before and we have 4. And dy by dx of any constant, even if it's 7 or 700, it will always be 0. So if we do plus 0, this just cancels out to get 6x minus 4. And that's our answer. Let's go to the second question. F of x equals 4x cubed minus 7x. Find the gradient of the graph at the f of x at x equals 5. So gradient of the graph is going to be f prime of x, or the derivative of f of x. That's 12x squared minus 7. Because we bring down the exponent, multiply by the whole thing, and then subtract 1 from the exponent. So that's just 3 times 4x squared, which is 12x squared. Similar way, 7x is 7x to the power 1. Bring 1 down, it doesn't change anything when you multiply it. And now 7x to the power 1 minus 1, that's 7x to the power 0, which is just 7. And since it's a minus, we put a minus here as well. So that's f prime of x. And now the derivative of x equals 5, so f prime of 5 is going to be 12 times 5 squared minus 7, which is simply 293. That's the answer. Question 3. The derivative of f of x equals x cubed minus 12x plus 5 is 3x squared minus 12. Find the coordinates of the turning point of f of x. Well, here we already given the derivative of f of x, which is 3x squared minus 12. So turning points, these will be where f prime of x, or the derivative of f of x, is equal to 0. That means 3x squared minus 12 equals 0. So 3x squared equals 12, x squared equals 4, and x equals plus or minus 2, which are the square roots of 4. So x equals root 4, which is plus or minus 2. Remember to include the negative one as well, because coordinates can be both positive and negative. So now we need the full coordinates of the turning point. So we need to find the y values for each x value. So for x equals minus 2, we get minus 2 cubed minus 12 times minus 2 plus 5. That's minus 8 plus 24 plus 5, which is 21. Now, when y is equal to positive 2, that's 2 cubed minus 12 times 2 plus 5, which is 8 minus 24 plus 5, which is equal to minus 11. So we have our two y values now, which are 21 and minus 11, and we have our x values, which are minus 2 and 2. So we have minus 2, comma 21, which is the first set of x, comma y, and then the second set over here is 2, comma minus 11. And that'll be our answer. Now let's go to the fourth question. A tangent is drawn to the graph of y equals x squared plus 3x at the point A. The gradient of this tangent is minus 5. Find the coordinates of point A. Well, if the gradient of a tangent is minus 5, that means the derivative, or dy by dx, is minus 5 at that point, or point A. So dy by dx is going to be equal to 2x plus 3, using the method to find derivatives, which I have shared previously. Now, this has to be minus 5 since the gradient of the tangent is minus 5 at the point A. Now 2x is equal to minus 8, x is equal to minus 4. Now this is the x coordinate. Now as for the y coordinate, the y is going to be equal to x squared plus 3x, and in x equals minus 4, it's minus 4 the whole squared plus 3 times minus 4. And in this case is equal to 4. So that's our answer. Question 5. Find the equation of the tangent to the graph of y equals 3x squared minus 5x plus 2 at x equals minus 1. Give your answer in the form y equals mx plus c. So to find a tangent, we need to find the gradient. So the gradient of any graph is dy by dx, or the derivative, which is, in this case, 6x minus 5, using the same method I told earlier. Now, dy by dx at x equals minus 1, gives us the tangent gradient, the tangent line gradient at x equals minus 1. That's 6 times minus 1 minus 5, which is equal to minus 11. So at x equals minus 1, the y value is going to be 3 times minus 1 the whole squared minus 5 times minus 1 plus 2, which is simply 10. Now we can substitute x equals minus 1, y equals 10, and m, or the gradient, is equal to minus 11 into y equals mx plus c. So we can write 10 is equal to minus 1 times minus 11 plus c. So 10 equals 11 plus c. c is equal to negative 1. So the tangent line equation is going to be y equals minus 11x minus 1. That's our answer. Let's go to question 6. A curve has equation y equals x cubed minus 6x squared plus 16. Find the coordinates of the two turning points. Alright, so turning points have dy by dx equals 0. And in this case, dy by dx is 3x squared minus 12x. And that's 0. So we can factorize this. 3x times x minus 4 is 0. And that means x is either equal to 0 or 4 to make the right hand side 0. So if this is 0, that means x has to be 0, right? Only then when we multiply these, we'll get 0. Or if this is 0, x has to be 4 to get 0 here, and the whole thing will be 0. So x is 0 or x equals 4. Now the y value when x is equal to 0, so y is equal to 0 cubed minus 6 times 0 squared plus 16, and that's simply 16. Now when x is equal to 4, the y value is going to be 4 cubed minus 6 times 4 squared plus 16, which is negative 16. And that's pretty much it. So the coordinates are going to be 0, 16 and 4, minus 16. That's our answer. And with that, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.